Okay, welcome to something we don't have a good name for. I think we kind of said it's going to be some kind of mini block talk or mini talks in a BlockCzech company where we would talk about various technology topics. The first one we chose in a voting is Solidity development tools and kind of Solidity development in general, because we are a blockchain company that mostly works on Solidity. So it makes probably sense to start with that. My name is Vaclav Pavlin, which all of you know, but for anyone watching outside of the company. So I want to focus on few kind of areas where we'll talk about some general tools for blockchain development, for Solidity development that we can choose from. And I think those are the most popular. Those are the biggest competition: Hardhat, Truffle, Remix. I'll talk more about them in detail in a bit. Then something about writing code, writing better code, making it easier for you. I have a big slide for testing because I think it's very important to be able to test properly, because I've never been big on tests themselves, writing tests in Python or anything. I didn't really care that much. But with Solidity and blockchain, we mostly work with money, and it's important to test what we are doing and not to deploy something that's going to break in some weird corner case. Something about how to deploy your Solidity, and then some integrations, which I think is mostly things we could work on in the future to make our lives easier. But we'll see about that. Okay, so from the general point of view, there are generally three main tools or set of tools, frameworks that we can work with when we develop Solidity: Hardhat, Truffle, and Remix. Let's start with Remix. Remix is kind of good start if you are really new to this and you just want to try to deploy your first smart contract or build something and run it and interact with it. It's basically a web IDE where you can write your code, it automatically compiles on save, and you can hit deploy and deploy it to your local machine, to a test net, to a main net, and you can basically do that very easily. And you can directly from Remix interact with the contracts. I personally use it as a sandbox. So if I have something in mind that I need to quickly try and I don't want to set up the whole new project, I just open Remix. There is a hosted instance that you can use, and I just open Remix. I create a new contract. I write a few lines of code, execute, debug, look at what's going on there, and then I'm like, okay, fine. I can put it in my actual project, right? The problem with Remix is that it doesn't really push on the best practices, like you should store everything in Git, it should be versioned, you should use branches and pull requests and things like that, because Git integration with Remix is very poor, if existent at all. I didn't really found much about that. So it's not a great place to do product development, really, right? For experimentation, it's great, but for product development, it's not great. Then we have two competing tools, Truffle and Hardhat. And I've started with Truffle, and now I moved to Hardhat. Both are used by big names like Uniswap, Aave, and others that have large code base, deploy multiple contracts, interaction between the contracts and things like that. And they, all of these use either Truffle or Hardhat. The differences are kind of that Truffle is more based around Web3.js library for testing and deployments and things like that, and Hardhat uses Ether.js. So I think part of your decision what to use would be based on whether you like Web3.js or Ethers more. Then also Truffle seems to be more opinionated. It doesn't give you that much flexibility. You can build some kind of plugins, but they are clumsy and kind of more tightly integrated into the system. And then Hardhat allows you to be very flexible. You can write scripts that you can then execute directly from command line through the Hardhat command line interface. They have a network kind of like EVM compatible network integrated into Hardhat that you can either start separately and deploy to that, or you can just use it in tests as part of your test run. Truffle does that too, but slightly differently, relies on another package called Ganache and things like that. So I like Hardhat a bit more uh, because it gives you a lot of options that you can, but you don't have to use, and you can be very flexible with that. So I'm gonna focus on Hardhat for the rest of the presentation. We can probably do a deep dive into Truffle in some next session if people are interested, and then we can decide which one we prefer in general. So writing code, I don't know if anyone has a specific opinion about a good IDE for writing Solidity. I use VS Code, Visual Studio Code, and it works fine. I can write code, I can store files, which is basically what I need, and it highlights the code and stuff like that, so that's fine. There is a Solidity extension that allows you to do linting and code formatting and even compilation of things and stuff like that, and that works for me sometimes. For whatever reason, I get weird Node.js error. I've submitted an issue with the Solidity extension. They haven't replied yet. So, but for some repos it works, for some doesn't. For me, so it's kind of 50-50 so far. If you want to write good code, you should ideally write the code based on some style guides that the language provides. So style guides from Solidity are based on PEP8 from Python. So if you're familiar with those, you should be familiar with the style guides for Solidity already. If not, then there is a documentation for that, and I definitely recommend going through that. It's not long, but it helps to get some clean style for your code, and that helps a lot. We often, as developers, suffer from not invented here syndrome. So we want to write everything, we want to try everything, do everything, but it often is not the greatest option to take. So I would definitely recommend to you using verified and audited dependencies. So one example that kind of everyone uses anyway is Open Zeppelin contracts. You can install them and then directly use them in your project, and they implement all of the various standards for EVM, like the various tokens and NFTs and accessibility extensions and libraries and whatnot, where you can easily go and take something existing and just extend it or use it in your contract. The reason is that if you want to write everything from scratch in other languages, that might not be that big deal. Although I still think that like verified and tested dependency is better than my code in most of the cases. But again, in Solidity we are dealing with money, and we really need to be careful. One thing that I
sorry, you are not sharing. If you want to share screen,
I'm not sharing the screen. Okay, so that's very unfortunate because I was basically talking about the screen the whole time. Sorry about that. So the previous slide about the Hardhat Truffle remix was this one. Can you see it now?
yeah,
Okay.
it's good.
So there is not much. Here I was talking about writing the code, so not much visuals either, just the links, so that if I share the presentation later with you guys, you can click on the links directly. So I was just right here at the end. I learned about it some time ago, but never used it, and I started using it basically last week. Hardhat Console. It's a great way to debug your, well, not debug, but to see what's going on with your contracts. You can import this contract if you use Hardhat, and then you can use a function console.log like you would do in JavaScript, and it will print out whatever you pass in as parameters. And you can also use format strings, so you can pass in numbers, strings, addresses, whatever. So if you are building something complex, let's say, and you want to know, like, did it enter this function or this condition? What was the actual address that I was interacting with? Let's say we are building some token that takes gas, that takes fee or taxes on transactions or transfers. I want to know how much was the fee without actually like trying to do the calculations of how much I put in and how much I should get back and things like that. So Hardhead console is really good for that, because it allows you to kind of dig deeper into what is your contract actually doing. I I then remove it when I'm done with that part that I'm doing. I remove it from the contract to not put it in production as a dependency or with some weird console log calls. I don't even know what it would happen with that on mainnet or generally on like deploying on an actual network. But for local development, this is a great tool, and I definitely recommend checking it out. So let's go take a look at testing. So since we are talking about Hardhead, and Hardhead is mostly using Eta.js, it makes a lot of sense to take a look at that. So you are familiar with the function calls there, or the API there. But obviously you will learn that as you go. Also need to get familiar with Chai, which is what Hardhead generally uses for testing some assumptions. So I can put in like, what do I expect the value to be, and then the actual value, and it shows me, or it throws an exception, or it shows me that the test step failed or something like that. Hardhead has a lot of plugins. I said that you can easily write more plugins by yourself, and these I found really useful when using Hardhead. One is Contract Sizer. The problem with developing Solidity smart contracts is that Ethereum, and by that all the forks, have a limit on the size of the contract, and that size is 24 kilobytes. And if your contract is bigger than that, it won't compile, and then obviously you can't deploy. It might sound, to some it might sound like a lot, and some it might sound like very little, but surprisingly often I hit that contract size, especially if you use those dependencies that I mentioned, like OpenZeppelin. You depend on a bunch of other contracts, you import ERC20, maybe some extension, whatever, and suddenly you are at 21 kilobytes and you still didn't really write that much code of yours. So it's good to check the size, and then maybe once you get getting closer to that, start thinking about optimizations, like, can this state variable be smaller? Can I remove some of the or can I change the naming of some variables so that they still make sense but the code is smaller? Can this require string, which basically gives you kind of like some error message when something reverts in your contract? Can this be shorter? Can it be just kind of a error code number that I can then translate maybe on the front end, or for myself find the mapping with an actual string somewhere else? A second plugin is Hardhead Gas Reporter, and that's super useful if you're trying to optimize your gas usage in the contracts, because I don't know if everyone knows, but every transaction on blockchain costs you gas fees, and the gas fee is mostly consists of how much you read and write and interact with the state of the contract, which are all the variables that you specify there that are part of the state of the contract. And as you interact more with them, and maybe you read a lot of them and then you write some and whatever, the gas fees go up for the transactions and for the function calls. And this gives you a nice breakdown of what did actually cost how much. So I think I have like an example here for the example project in Hardhead. So it's just called the set greeting once, so there is no min max, it's just average, or actually two calls, weird. But basically it tells you how much it will cost to call this function on mainnet, and then there's how much would it cost to deploy this whole contract. And if you have more functions, you see the breakdown of them. If you run multiple calls, it will give you min, max, and average for all of them, because it may change on like what code path you take, some conditions, some checks, and things like that. The cool part of this is that you can actually connect it to CoinMarketCap through an API key, and it will pull the price for the token that you would pay the gas in, and it will also It can also connect to some gas fee website, to the API, and it will also like take a look at what is the gas price right now, and it will calculate the actual price for you. This is, by the way, the contract size plugin. So this one is really small, so it doesn't really have much. But I was working on an NFT contract that I got to 22 kilobytes, and I had to start optimizing to make sure that I don't hit the 24 while adding the code in there. And then another one is solidity coverage for tests, especially. So if you're building tests, you want to cover the whole contract with the tests. You want to cover all functions and ideally all the paths into functions as well. So this coverage plugin gives you a good overview of like how much of your contract is actually covered. I don't have an example right now, but I can probably find something a bit later. But basically, you run it, it runs the tests, and then it computes like your contract is covered from 66%, and it also gives you a nice web page report where you can see which lines are covered, which are not covered, and like if there is a path in the function with like if conditions and required and things like that, that would not be tested because you didn't cover that path, you didn't test that condition both ways, like true and false, in the test. So this is really, really useful if you want to have good coverage of your code. And I'm not the kind of person that would require 100% coverage of code generally, but for Solidity it feels like something that we should try to achieve always, because if there is a weird path that we didn't test, might be then used to for some malicious purpose. Another testing tip or tool is that it works for Truffle, it works for Hardhat as well. Since you run your own blockchain, you can control the time in the blockchain. Obviously, you can control the blocks as well. I don't think you can rewind the time, but you can jump to the future. So let's say you're building a vesting contract that should vest every month, and the whole vesting should be 2 years. You're gonna find this very useful because it's the easy way. You can call a function. You can call the local network basically that will call this function to kind of jump into the future. So you can jump into the next month and see whether your tokens actually would get vested in your tests. So it's super useful. Another option is basically to just like mock the time and provide the time to the contract externally. So override a function loading the time, let's say. That works too. I'm a bigger fan of this, but the other one, as I was told, is useful if, let's say you are a regulated entity like a bank, and you want to make sure that the time you're using is actually real time. So you may want to use some Oracle to give you the time and not the network, because the network, the blockchain network, can go back and forward in time by basically the block time. So for Ethereum, I think it's like 15 minutes or 15 seconds. Sorry, and that means that people may game your contracts if they are based on time. So first of all, you shouldn't be based on time. If you need to be based on time, like for the vesting, you may want to use some external source of truth for time, like an Oracle. But even if you don't want to do that, then for testing, it is good to know that you can jump forward in time. I have it here as well. So the Hardhat console for writing code is kind of this. I forgot I put it in the testing part. So like the console log. There is obviously also a Hardhat console, as in a command in CLI where you can run that, and then whatever you're doing in your tests, you can basically execute that in the console and interact with the contract directly. So that's also useful for debugging things and trying things out. One thing that I really like, and I have used it multiple times lately, is forking the mainnet network. So if you want to interact with something like PancakeSwap or Uniswap, you have two options. You can deploy all the contracts on your local network, which is going to be hard, time consuming, and probably not work great because you may miss some stuff. So unless you find a good documentation or good way of doing it automatically, it's not worth it. The second option is that you kind of fork the mainnet. So basically the network in Hardhat and also in Truffle, the Ganache component of Truffle, what they can do is they basically, if you interact with a contract on the mainnet, it will download the state and kind of put it in your local, copy it to your local environment. And then when you interact with it, it will not go to the mainnet, although it has the state, it is kind of backed by the mainnet, but it will use the local copy of that contract. So if you need to interact with it, change the state and everything, it will allow you to do that without actually communicating with the mainnet. And that's super useful because if you're testing a token, you can develop like a mock swaps and mock liquidity providing and stuff like that, but it will always be fake. If you want to test it for real, like how will it actually behave when we interact with real contracts, with real DEX or AMM? This is a great way of doing that. And the only thing you need to basically provide is a link to a node that you have access to. So there are services like ChainStack, Alchemy, and many others that allow you to register with your credentials, and it gives you a developer account with few 100,000 requests a month, which should be enough, that you can basically use and just interact with any contract that is deployed on mainnet without actually talking to mainnet. Then when we are at the testing, I think security tools are super important. My only experience is with Slither right now because that's free and I can install it and I can run it locally, but I've already found few potential issues. They may not be issues really, but they may lead to some problems. It basically is a database of various paths how to hack smart contracts, and it looks for patterns that lead to these hacks or lead to these security issues. And then it gives you a list of those, like which line and what can you do to fix it and things like that. And then there are many more that do the similar stuff, but are paid, so maybe they're better. There are services, so you have to run them locally and things like that. So those are things that I need to look into in the future as well. And then there is another thing called fuzzing or fuzzy testing, where you basically just throw a bunch of random inputs on your method, and it kind of tries to break it, which I think is very interesting. Maybe not for some basic stuff, but as we get into more complex contracts and interaction between contracts, it's important to know that some random value that overflows, underflows, or something would not break the contract. From the deployment perspective, there is just first deploy to your local network because that doesn't cost you anything. Then you may deploy to testnet, but that costs you testnet currency, which is kind of hard to obtain, at least as far as I understand. So don't waste it if you can test locally. Verify your contracts once you deploy to actual mainnet. There are plugins for that as well, for Hardhat and Truffle, where it does the hard part for you, because if you go to Etherscan or BSC scan and you try to verify things manually, it's a tough job, but these plugins can automate it for you. My biggest kind of wish is for people to make things reproducible. So if I'm reviewing someone else's PR, I'm hoping I can run 2 commands and get to the state that the person kind of expected it to be. So if the person forgot to push some file or change something last minute, I can see that immediately, and then also I can play around with the stuff if I'm able to quickly set things up. If it takes me hour or 2 to just deploy the thing I'm reviewing, then I may spend less time on actual review, and that obviously hurts the PR or hurts the project. So make things simple and reproducible, and the tools I was talking about kind of makes that for you. The last kind of slide and the last part integrations is kind of what I'm thinking about, what we can do to simplify our work. And I'm pretty sure that some of that will already exist and we can just reuse existing components. I haven't dig deep into that yet, but I believe that that I can find some solutions. And if not, then it's a great place to start building something for helping ourselves and helping others, maybe even for with development. So one thing is type chain. That's already existing thing. Hardhat truffle, you can use it in both basically. Hardhat uses it basically by default. It generates a type definitions for your contracts for React. So if you're building a front end in React, you would immediately get the type definition, so you don't have to kind of go through various hoops to get and call the contract functions, because you already have the types and they kind of return nicely and everything. I'm not sure if it's my problem with the Solidity extension in VS Code, but the how do you call that? Not recommendation, but like when you type and then you hit some button and it gives you options what you want it to type potentially will not work for me for the contracts. But I'm hoping that the type chain works like that if your extension actually works, so that if you're trying to call some method on the contract, it makes it much easier, and you can see based on the documentation like what are the actual parameters that you should put in and things like that. I think, I'm not sure, but so far from what I've seen, CI is not a big thing in development around blockchain in general. So I would like to focus on that a bit more. So things like if you submit a PR, the contract should be compiled and tested before we can merge the PR. I think that's super important. Then you can also immediately verify, like look at the tests that the CI ran, and you don't have to run it locally in case you just want to check the code, and maybe you don't need to download it and run it locally if the CI does it for you. And then also we were talking about that, I think with David, that basically in front end you need either ABI or the type devs from type chain to be able to interact with the contracts. And it's sometimes hard to keep track of like, okay, so we did this change in smart contracts and now we have to, like the front-end developer has to go and download the contracts and compile them, or download the ABI or do something. So maybe we can build, maybe we can build a CI that as we merge a PR in smart contract repository, it will also submit a PR to front-end repositories and potentially back-end repositories with the ABIs and type devs and whatever is necessary there. To be able to interact with the new version of the contracts. I think that would be helpful. And there is another dot, which I wanted to put like 3 dots after that. So like there are many options of like what we can do and automate. So if you all want to think about that and give ideas, I'm definitely open to that. Okay, last thing, I wanted to just show you the structure kind of how it looks when you get the Hardhat project generated. So what you can do is you can do npx, you just install npm install Hardhat. I have it installed, so it doesn't make sense. Npx Hardhat init. I don't think it's gonna run because I already have, I already have the project initialized, but maybe it will. It won't. Okay, and it gives you some options like create a sample project, create a more complicated TypeScript project, things like that. So I've generated a TypeScript project, and what you get is the contracts and the tests and the scripts and a bunch of predefined files here. It also installs some of the dependencies for you, which is great. And that's mostly it. So like there is an example project that you can immediately compile and try around. There is some basic testing, which kind of gives you a glimpse of what you should, how your testing may look if you are writing the test, and it gives you the deploy script, which is also pretty simple. Just get the contract, deploy it, wait for it to be deployed, and and then print. As you get more contracts and complicated connection between them, it's gonna kind of grow and make it more interesting, let's say. And I think that's it. As I've been playing with that, I basically just added some configuration for the gas reporter, so you can see that you need to talk to the Explorer API for the gas price, and you need to talk to CoinMarketCap for the price of the token, which for me here was BNB. And then to fork the mainnet is really easy configuration. So you just define a network, set as forking, and give a URL to a node, and it will basically allow you, when you use this network, which would be basically like this. So npx harded network test, and I'm basically using a fork or a copy on write, I would say, version of the Binance mainnet, Binance Smart Chain mainnet network. And this is how the output from the tests look like. Yeah, this is again the gas reporter. Okay, that's all I have. I'm not sure if it was what you expected, guys, but I don't have anything else. Any questions that I